share screen.
Just record it.
Yeah, please do. This one. So what I want to get into is we had a small discussion about comparing those two models with my model. And I like, actually, I do want to get a bit deeper in that. Not so much this part. That was this part we had compared. And start with a real use case. Oh, hi, Stephen.
Hello.
So I want to go back a bit on the comparison of models because I'm realized I was a bit fast in comparing models, and I do want to, and I have a use case in mind that makes it worth it to go over this over again. This morning I was reading about dog whistles, and I'm thinking, how do we model an argument about dog whistle? That is, if we have this sentence can be interpreted this way by these people. That's a statement about interpretation. And that's something that can become an argument. And modeling that as an argument, not as a meta argument, but as an argument, the argument side of the meta argument, if you will. And that's the use case I want to visit. Do I need to be more specific? I mean,
I think it's clear, but how is it not modeled by simply having a claim with the text exactly what you just stated?
It is, let me think.
So the use case you have to present is why does it need to be more formalized? Like, as in, how do you want the system to act on the formalization? If the system doesn't need to act on the formalization, there's no real point in formalizing it. I think we had a similar discussion before, right? So to argue for the use case, you need to show, if the system knows this because it's formalized, we can do that.
Right. It's, and my answer to that actually, as usual, is can the interpretation be contested at this level? And that means it has impact on what's the use case really? Somebody proposes an interpretation like this. Sorry, let me cut the pauses. Somebody says this sentence, which has this innocent interpretation, is also a racist slur. It's also a dog whistle. So it's proposing new interpretation. So it's proposing to unify two claims, one that sounds innocent and one that isn't. Like one of the classic dog whistles is any statement about international banks, which is a dog whistle for Jewish conspiracy. So, you know, international banks are endangering the economy of our nation is actually, there's an interpretation, which is Jewish conspiracies are threatening the economy of our nation. And somebody would say, this is actually another sentence that for that other claim. And people are, no, that was an innocent sentence in context. So the interpretation becomes contested. And the question is, do we unify those claims or not? And of course, what I want to do is make the interpretation a contested object. But good point, we can, well, the question is, if we don't formalize and we just have it as a statement, as you propose, do we unify the sentence in the claim or not? And that's a question I'll ask you. Do we, like, if there's an interpretation that is highly contested, do we put it on in the model?
Yeah, that's argument modeling, no? I don't see the problem.
No, what I'm saying is, do we unify them in the model? Like, do I put the contested sentence, such as international banks are threatening our nation's economy,
But
in the
what is
same claim as the Jewish cabal conspiracy is threatening our nation's economy?
These are two separate claims. I guess I don't know what you mean by contested. And
no, I think Marc-Antoine is saying, like, does the model say these two are equal or not?
Yeah, if the equality is what is being debated.
Yeah, okay, but okay, so but when then yeah, so we're talking about process. So again, that's
no,
why
it's not process. It's about that's what I keep saying.
Okay, we don't have to name it, but so you're assuming that the equivalence between these two claims is modeled.
Yes,
So
there's an argument saying
yeah.
those claims are the same, and there's an argument saying those two claims are not the same. And my question is, forget those claims. Would you put them as, because somebody says this is an interpretation of that means those two claims are the same?
Yeah, but that is what I call process. So the way I see it, the way I see it, you would either model them as the same or not. It's a binary thing, right? So they either assume the same or not the same. If you then want to argue they're not the same, yes, you can have an argument map about that, but it's never resolved in the original map. I mean, at some point you need to make a decision whether they are not the same. So,
okay, so
that's why for me that part I call process.
No, and what I'm saying is I want to express the fact that this is contested. It's not the same to say it's the same, it's not the same. It's
Yes.
There is agreement about.
Then there would be a claim that says that claim is the same than the other claim. That is the claim.
Yeah, that's right.
And then you can argue for and against that.
Okay, so you would have in the claims, so you would have a claim equivalence claim.
Yeah, you could say that. Yeah.
Yeah, that's a valid answer. Okay, so that's how you would do it. And so,
I think Timothy as well, but we might have to check in with him.
Yeah,
Timothy?
Absolutely.
Like, how would you, if you want to model the potential disagreement or agreement on whether two claims are the same, how would you model it?
Like you said, it's a process thing, so it depends on what you want the process to be. So if you're going to have a master curator class, you wouldn't debate it. They would just come and merge or not.
It is not a process claim.
I think the point that Marc-Antoine is trying to make by saying
I understand. He's saying these two things are the same. Okay.
You can model it, regardless of whether it's part of process. Suppose you do want to model.
Honestly, here's how I would model it.
Yeah.
Ideally. They would be the same or not the same based on their disambiguation. So I would model it through disambiguation, right? So then there's a process question about, what is the process of disambiguating, right? But at some point, if it's fully disambiguated, it's the disambiguation that represents the claim and not the words used in the claim. It's not the statement. That's how I would model it.
Okay, that's extremely interesting. What you're saying is that in this model, the claim's meaning is not captured by the sentence, but by an extra thing which is not in the model yet.
Right. But I understand that's idealistic and may not match a process that actually works, which means, for example, what happens if people put in sentences that have nothing to do with the disambiguations? What's the process for weeding out stuff that doesn't match or doesn't make sense, right? Now, the argument or the claim that these two phrases mean the same thing is different from these two claims mean the same thing, because you're right. Somebody could just come in and say, like, this person said that, and I think they're saying this other thing. So you could say, like, President so on and so forth said this, and I believe they are making this claim, and you're pointing to a claim. In that case, you do have to reference a claim, right?
Yeah.
In that case, though, you're not targeting you're not saying two claims are the same, what you're doing is you're bridging a statement to a claim, a set of words, a series of words to a claim. You're making a connection between two things.
I'd actually argue that there are two claims associated to the state, two distinct claims associated to the statement. And maybe that's more accurate than saying the two claims.
No, that's two different things though. No, that's two different things though, because one thing is saying this claim is the same as that claim. That means you already have a fully disambiguated claim in the system. You have a partially, I would guess this would come, if you have two fully disambiguated claims and their disambiguations are different, they are by definition different claims.
Right.
But if one is partially disambiguated, and what you're saying is, I think the completion of the disambiguation will make it identical to this existing claim, then you're referencing two claims. And your purpose is, I think when we fully disambiguate this, we'll see they're the same claim.
What I'm saying is, when you say, okay, the president says this and he means that, and you said, oh, I'm equating a sentence to a claim. What I'm saying is, I think the point is the sentence has a innocent interpretation, which is another claim. And you're saying with it actually, there's a subtext, which is this other claim. And I agree that maybe it's not the same as claim equivalence, it's more claim implicature, which may be something we need to define.
I mean, you could say, I think when this person said this phrase, they wanted people to interpret it as this claim, right? It's still the same claim structure. It's just that the words in between have changed a little bit. The intention,
Yeah, so we have an implicature operator, which is distinct from the equivalence operator, I think.
Right? I don't know about that, because implicature, as you said, is a measure of intention, and intention is by the claimant, which in the canonical debate model doesn't exist. You can, however, you can have a, I mean,
yeah, I think that you don't have to have a claimant. I mean, I think interpretation is always by someone, and you may choose to erase the someone, but the notion that claims exist without interpretation or without intention is,
yeah. Let me modify that. Essentially, what that structure is doing is it's assigning a claim, and it's assigning well, again, it's a specific phrase, right?
Yeah.
So it's not exactly a claim. It would be a sentence. It's assigning a sentence to an entity as an emitter of that sentence.
Yeah.
And then moves on. But
you
all those are...
You don't need the emitter, right? And you don't need the rest. You don't need, for your purposes, you don't need to say who the emitter or the receptor is. You don't absolutely need to. I think it's a good thing to do it, that we differ on. But if you're saying, I don't have this, I don't think that's a closing argument. Like whoever said, and I really like my example, international banks are threatening our nation. Here it's understood that we have enough context to know which nation we're speaking of. And there's a literal interpretation that's more or less innocent. And there's implicit interpretation by anti-Semites that, international banks refers to international Jewish cabal. And that's how they interpret. But you don't have to say by who. It's just some people, undefined, undetermined, interpret it this way. But the fact of the interpretation is something worth
it's something that to me is just another entity in the disambiguation.
Yeah.
And it is like Stephen said, it's just another claim, right? The only component that's interesting is you're referencing a claim, right?
Yeah. So what's clear here is that you've referred to something you call not context this time, you use a different term, trying to remember. But, you know, something that the disambiguation. And so that's something that's not explicit in the model yet. So maybe we should start looking at what would that look like. I'm not happy with my model, by the way, at this point. I have interpretation as basically a relation model, but really, I agree with you, it's a claim. So where would I put it? And I said my model was equivalent to yours, or to Stephen's, because I have basically thought proxy and many-to-many with sentences. And basically, I'm reusing sentences, he isn't, but that's not a big deal. But I have the equivalence class as an explicit thing, which is equivalent to his claim. But what is interesting is his claim has the negation internally, whereas here I have the negation as a symbol relation, whereas I really need negation as a thought proxy relation, or actually as a claim negation, because entities don't need negation. We have complement under some set theoretic operation, that's different. But claims have negation, but I need a claim relation, which I don't have here, or no.
When you say you need it, what's the because there?
Good point. Because I don't want to be, well, because all the issues of negation that we've dealt with in our other use cases are still relevant, basically. They're still relevant to my model. Here, I have a negate operator, which works, but it's very unclear how it is. And what I did is the notion of logical variant and topic relation, but this is basically disconnected at this point. This was work in progress, really. The previous one, I think, had, yeah, logical variant, including negation as a special case of logical variant that was associating a claim to another claim. So that's where I had the negation. So all these are topic thought proxies, right? And the entity, the claim, and the argument are all thought proxies. So here is where I had the relation, but there's other relations, right? Distinction, specialization, parametric variant, implication, I think is one of them, or subtext or something like that, right?
So the reason then that you want it as a, I forgot what you called it, is because you consider negation one specific thing of a more abstract thing, which you call logical variant, and you want to operate on logical variant. What operations do you want to do in logical variant? Like, so I understand the argument that yes, if negation is a more specific case of an abstraction that's useful to model, yep, then my question is, what's the usefulness of the abstraction? Like in this case, what's the usefulness of logical variant?
It's because we have another concrete subclass, which is the probability variant. And in that case,
so you want to treat both negation and probability variant in the same way. So I'm asking, in which use case you want to use negation and probability variant in the same way?
I have an example that might fit, which is another logical variant is the comparison, right? Where we know that A is greater than B, or A is equal to B, or A is greater than or equal to B. These are all possibilities of a logical variant of comparison. And we know that you're going to have mutually exclusive claims in a set. There's a set of claims that fit into that logical variant. Right. And that affects how arguments affect them. Like you should know that an argument for equals supports both the equals and the greater than or equals and the less than or equals, but opposes the rest, right? So that's how I see logical variant working.
I was having those more in the parametric variant, but maybe those should be unified, Tim. I agree totally.
They're separate. That's a different kind of logical variant. You're right. That's another one where, you know,
Yep.
it affects how arguments affect the rest of the set. But again, you know, the comparison is another variant.
Yeah, but it's true that, okay, to try to get back to Stephen's question, when I have an argument, I ask, and remember my arguments are single rows, right? So I may say, are those arguments of the same basic form? That is, do they involve the same premise and the same conclusion? Like, so the notion that same premise, same conclusion, modulo logical variant, whether it's negation or probability or whatever. That's
So
why
whether they have the same base claim basically there.
Yes, exactly.
Yeah, which is actually shown as the common interface between the two indeed.
Yeah. So
when
that's
would
my
you
answer
want-
to your question.
So that would support like a use case in finding all, yeah, well, logical variants of a certain base claim. So you can not only, to make it concrete, if you find the world is flat, you don't only find the world is flat, you can also automatically find the world is not flat and the world is
10% chance that the world is flat.
Yeah. Okay. So do you have so I understand it now. Then I still wonder when that so I understand the usefulness from a system perspective. So now I'm wondering when
Can I make a little parentheses there while I have you understanding and we're all talking about this logical variant?
Yep.
This is the reason why I see a certain advantage in modeling the negation as a separate claim instance, because as a logical variant then works the same way. What is the negation logical variant? It means there are two mutually exclusive claims. They're mutually exclusive, and so a support of one automatically opposes the other and vice versa. And that is like the trivial version of a logical variant. Everything else is sort of a more complex expression of the same concept. That's right. Basically why I was interested in seeing them as separate entities.
And the reason I was a bit resistant to your version is you do it at the symbol level, because this is single sentence, whereas I want to do it at the thought proxy level.
I'm not certain I got that. I was distracted by the sun.
See, if we come back here, right? Mm-hmm. This claim is a single sentence and the equivalence class is implicit, right?
No,
so
I meant what Tim said before you.
Okay, so let's first finish what Tim is saying before we move on to my point. Fair enough.
So logical variant defines a relationship between different claims that follows rules in term that has an effect of what is the relationship when one of those claims is supported or opposed. You know,
okay, so but that relationship is not encoded in the base logical variant, right? That's encoded in the specific. So what would the interface be of that relationship? Because understand that, as shown here, that they both have a base claim. So understand that indeed you can find all logical variants, if you will, of one base claim. And I understand there is a relation. The relation is specific to whether it's a negation or a probability variant. So it doesn't explain how you will handle that relation on a, it doesn't explain the need for the abstraction, is what I'm trying to say.
So it comes down to organizing the arguments made to that set, on that set of claims, right? A logical variant essentially defines a set of claims with a relationship, right? And so,
I think a specific logical variant might be able to.
Well, the interface, no, the abstract notion of it is that it defines some kind of relationship between these a set of claims.
So no, I don't see that in the abstraction. I mean, in the case
You don't
of
see it
negation,
represented here. You don't see that in general and how it could be used.
I wonder what the generalization is, being the need for an abstract.
Okay, wait. So let me
variant.
do this. Okay, you logical variant is a set of claims, right? And somebody then proposes an argument in support of one of those claims, right?
Okay, but already now
wait.
what is modeled here in the current diagram isn't a set of claims. The logical variant refers to another claim and attaches some variant
But,
to
but
the
the
logical
back
variant
arrow
is
of that is
Okay.
a set of claims.
If
If you
find all which set, like how do you find like
right now it's
has
a
a-
diamond, but I mean, suppose you
Yeah.
traverse that arrow backwards, you get a set of
Yeah.
claims.
of all all probabilities, of all negations, of all any other
Yes.
ones, right? Okay,
Yes.
what do you do with that
Yeah.
total set of claims of
So
specific?
then you add an argument in support of one of the claims, right?
The specific ones, yeah. Like a negation.
One specific claim within that set, right? Now, what happens is the implementation, the specific subclass, would follow its rules as to how that impacts all the others, right? So it could be in the case of the comparisons, and we'll take a simple comparison, right? We'll assume there's no greater than or equals or less than or equals, whatever. But you add an argument in support of it's less than, right? That specific variant says that an argument in support of less than is automatically an argument in opposition to the other two possibilities.
Yeah, but my pointer is that doesn't operate on logical variant, it operates on the specifics. You cannot automatically decide based on, you're not operating on logical variant, you're operating on all the specific implementations of logical variant. If you have a set of a base claim, of a negation, of 5%, of smaller than, all of these, that's one set of logical variants to one base claim. Like, and
I would have
say about all the other ones.
No, I would have.
What you're saying is logical variant is an abstract class, but what I'm saying is saying I'm propagating on all logical variants is a perfectly valid operation, even if there's no
propagating what?
If logical variant is an abstract class, it just happens to be handled differently by the concrete subclasses.
Yeah, but what's the interface? What do you propagate to the abstract? What's the interface? Right now, there's only base claim. What's the method that you're going to implement specifically for each specific underlying thing that will allow you to do this?
That's a valid question.
I would probably have I think the abstract method would need to be add supporting argument to specific claim contained within the set, right? So if you have claims A, B, C, D in the logical variant set, the operation would be add argument in support of claim A. That would be the method. And that carries through everything, including negation. And this is why I said negation is a logical variant that has exactly two claims in the set. And the relationship is defined as mutually exclusive. So if you add an argument in support of the affirmation, it automatically reflects as an argument in opposition of the negation.
Yeah, but you're implying that you group sets per specific type. You would have a set of all probability variant, you have a set of all, well, and that's already wrong because you have a claim and it's negation.
You have a negation relationship, right? A negation variant. You would have the comparison one, especially if you're doing greater than or equals or whatever, every claim would have its negation, would have a logical variant negation set. And then there would also be the relationship between these negation sets. So you can add an argument in support of the negation of less than, which means I don't know what it is, but it's not less than. You can make an argument that is whatever it is not less than. So you're supporting the negation of the less than claim, right? That would have an impact on all the other claims within that set.
I don't see
The rules are
I would
embedded in the
I would really have to
implementation.
see the abstract classes, because to me it sounds like it'll always be type checking on the specifics, and that's what it boils down to. And my whole point is that the logical variant abstract class is not useful beyond what is shown right there, that it operates on the same base claim, but that can give you a set of all the different.
No, because a claim could have, for example, a collection of all its logical variants. And then whenever you want to add an argument in support of a claim, it goes through its collection of logical variants, and on each instance calls add, this is being added to me, this is being added to me, this is being added. So all the variants would go through their process of calculating impacts on other things.
Yeah, in the case, suppose that the support is, this was observed in this case, and this case, and this case. Well, it may impose bounds, for example, on probability. Like if it was observed in so many cases out of so many, well, then the probability cannot be any variant where the probability is less than that becomes opposed. Whereas other probability cases where it's at least this, then are not opposed. So there's a method, how do you react to this observation? And that is common to negation. Like in negation, maybe if it's being observed, then the negation becomes strongly opposed. And if it's probability variant, well, they become so much less likely because the observation set imposes bounds on the probability variant. Now, this is contrived a bit, but the notion of you have to look at each subset, that's polymorphism. I mean, of course.
I understand polymorphism. I don't understand the polymorphic interface. And I still haven't.
Think of it as an event model, right? What is the event? The event is added an argument to this claim. In other words, this claim is the conclusion of a new argument. That if we're doing scoring, for example, huh?
What is it called? Because I mean, so give an instance. You add an argument to a claim, and then what? All the logical variants are notified of argument added. Is that what you're saying?
Yes.
All the logical variants that include this claim,
so including the negations, the probability variants, all of them, right?
Yes.
All of them. Yes.
Okay. They get notified that on the base claim
there was a pro, there was a pro or an example, and this and that.
Then what?
And then they interpret locally, like suppose it was in support. Now, in the case of the negation, their interpretation that becomes an oppose. But in the case of the probabilities, it can become a support or oppose depending on whether they were high or low probability. And it may even give specific numeric bounds. Like if it was said, oh, this is 20% likely, and it happens so many times, you keep a tally of how many times it happens. Well, it cannot be 20% if it's been so often, but it can still be 30% or 40% or 50%. So those are unaffected.
No, okay. Socrates is a man. That's a base claim. It's 100% certain Socrates is a man. You add to a base claim Socrates is a man because Socrates is human. I don't know. It doesn't make sense. The other way around. And
those cases don't have.
The base claim would be
variance.
Socrates is mortal. The base claim
Socrates is mortal, and there's a probability variant that says it's 99% certain Socrates is mortal. There's a negation Socrates is not mortal. Now you add a supporting claim to Socrates is mortal. Well, Socrates is human. Okay, the negation receives Socrates is human, got added as a supporting claim. The negation then says, okay, this is an opposing claim. In the case of it's 99% certain, what happens? Socrates is human, got added. What do you do?
Well, if, for example, the case is, well, no, I think in many cases, probability variant will be a probability distribution, right? And the question is, does it overlap or does it not overlap? If we have, in this case, a certainty that Socrates is immortal, then the 99% becomes negated because it's not 99%, it's 100%. I suppose it's a peak distribution, right?
Like, I feel like probability variant muddies the water. It's not a clear example. Can I really propose a clearer example? Another type of logical variant we've talked about is the parameterized claim, right? So it's the price of this is $10, $20, $30, right? Also, the price of this is at least $20. Okay, so those are 4 claims. They all should fit into a set of mutually partially exclusive, right? Because the greater than 20, it's at least 20.
I'm not
It's not
disagreeing
totally
with that.
exclusive. Okay,
not
so far, wait. Now let me give you an example of how, essentially this works. Is the problem you have with a set of claims like that is the cardinality issue. Is it cardinality? No, combinatorial.
I understand, but my question is, how do you treat that combinatorial problem the same as with the negation? How do you deal with the abstraction? I'm not disagreeing with that's a useful abstraction, but how is it the same?
Because what you have is, you want to just add an argument once and be done.
Yes.
You don't want to deal with the combinatorics of adding a copy of the argument to each and every place it impacts. You just want it added once and you're done, right? So what happens when you have this situation is, it's I looked at the story yesterday. It was $20, right, as an argument. That what you make that argument in support of the $20 claim, right? But you've implicitly made that support in support of the at least $20 claim. You've implicitly made that argument in support of the negation of the $30 claim, and you've implicitly made that argument in support of the negation of the $10 claim. All these things happen at once, correct?
Yes, but
so you have the claim, this thing.
They don't happen on the logical variant. In one case, they happen on negation. In the other case, they happen.
No, but if you want,
no, it happened on the simple claim. It didn't happen on the variant. It happened on the simple claim that this thing costs $20.
That is part of the variant, right?
You add the argument, this thing, I saw it at the store, it was $20. You add that as an argument in support of this thing costs $20, right?
Mm-hmm.
So if you aren't looking at the context of all the other possible outcomes and you're only debating, is it $20 or not? It's opposing the negation of it's not $20. That's the simple view you're taking. But if you want to represent a view that includes all the other possibilities, at the same time, that argument shows up as an opposing argument to the $10 claim and as opposing argument to the $30 claim. So you need a mechanism that joins all these things, and you don't have to reproduce the same argument over and over and over again.
I get that, but I don't see how the logical variant intermediate abstraction solves that in any way. That's what I don't see. I do get that, but this is not how I model it, because
well, how would you model that then? What is the
probably as a set of sentences, like you keep saying, it's a set of claims. So it's a set of claims that have a certain relationship towards each other, and each of these sentence claims has a negation.
The logical variant is a set of claims.
No, that's not true.
It has a collection of claims.
No, well, not in this.
It induces a set of claims.
Exactly. A logical variant is a claim in this model shown here on the current screen.
Yes, but it induces a set of claims.
Yes. From that, you can infer a base claim, which is not itself not a logical variant, and all of its logical variants, which can be negations, which can be probability variants, which can be whatever. You have that all set, and you can even group them per specific type if you want to. And then you probably still want to include the base claim as well as being part of that set. But okay,
so the issue here is the subclassing claim.
Yeah, what I'm saying is the logical variant here, the only useful interface here is the fact that they share a base claim, as in forming the set. But everything you're mentioning requires an understanding of the relationship of individual claims within that set, which you cannot resolve with your logical variant abstraction here. That will be a specific of the set you're modeling.
I think it would help a lot if we made some instances together.
Yeah.
No, but one second. What I think you're saying is logical variant. Okay, it's just the base claim for now.
Yeah.
For you, that's not a good enough reason to have an abstract class. For me, it is, by the way.
Well, that's why we deviated, right? And we went into other examples
but I do think that I expect abstract methods there. It's just this is not presented as a this is work in progress. This is a complete model. And as I said, it was a perfectly valid question to ask, what are the methods in logical variant? But we're trying to define them. And you keep saying, well, as it is, it's useless because it only has the base claim. And I said, well, we're trying to define the other methods.
Yeah, and you suggested add supporting argument, and I don't see how that method would be implemented in the strategy.
And we're trying to run through the logic of that. The logic of that, let me modify a bit Tim's example. The one I think which is very, with the current CO2 output, there's 50% chances we'll reach 2 degrees climate growth by 2050. That's a very complex claim, but it's one where we have both parameterization and probability, right? So now if there's evidence, and then there's variance, which
the parameterization and probability is modeled within the probability variant, right? Not in logical variant.
The parameterization is in the parametric variant and the probability variant. Like the only thing that's handled by the probability variant is greater than 50%. Everything else is handled with parametric variant.
Is this one claim or 2 claims you're talking about? Because these are 2 separate clauses.
It's one claim. It's saying with the current CO2 output, there's 50% chance that the feedback effects will lock in more than 2 degrees by 2050.
Okay, so this is some type of composite claim that includes parametric variance and probability variance. I hear you implying.
Yep.
Okay.
Yep, absolutely. And then there's another one that is the exact same parametric variant, right? It's still 2 degrees. It's still current CO2. It's still 2050.
The exact same parametric variant. A claim that contains the same exact parametric. Because we're talking about a composite claim that seemingly.
Okay, let me write it down, because right now it's getting confusing.
Yeah, again, instance diagrams are way more useful than this for discussions like this. But one thing still for Tim's example, I mean, if you have a set of claims and they impact one another, like smaller than, greater than, where do you model the smaller than? One claim being the smaller than set and the other one the other side, or because that's the relationship between the claims, which I don't see whether this modeled, or how the logical variant abstraction, this current diagram, even take care of that.
Yeah, the abstraction doesn't take care of it. The implementation would have to define how that works.
Yeah, and I don't see how that would work through specialization. The strategy pattern in this case, this is not an implementation that my intuition is telling me this is not a strategy pattern. Let's put it that way. If it's a set, I would model it as a set. Like you said, Tim, logical variant is a set of claims. I would model a set of claims somewhere.
But it needs rules along with it. It's not just a set. It's obviously a set of claims rules and with roles.
Yeah. It's an induced set.
Yeah. So we agree with each other on the
use case
specific subclasses. We only disagree if we need an abstract.
Yeah,
class.
Exactly. Yeah, well, I agree on the use case. I don't know specifically how I would model it, but definitely has some type of set. Because
I mean, they all share the same concept, right? The abstract class is there right now because they share
the base claim.
No, I don't think there is a base claim. I disagree even with the base. I don't know why it needs a claim. To be honest, I don't see why it's a subclass of claim. It can't be true. It's a set of all possibilities. It's by definition true, right?
Okay.
By definition true. You can't have a comparison.
But then we are talking about different things, because what Mike Antoine is presenting is, well, it is a claim, right?
Yeah, what I'm saying is here would be the base claim, which is parametric. Here is, and this is CO2 output would probably be a number as well, but right now I don't have a number, but let's say it's so much, and people could disagree that the current output is that much, but that would be another parameter. So that would be a base claim. this is a probability variant of that. This is another probability variant. So they're both probability variants of one another and of the base claim. And here's a parametric variant of the base claim where I'm saying it's not, and actually I could simplify that, which we have another base claim, which would be a parametric variant of the original base claim. I'm changing, or I could say 2.5 degrees, or I could say those are different parameters, right? Which I could vary. And I think it is, if we have something that reinforces this, and actually let me put, if I have something that says, well, we have evidence that the chance will be around 60%, well, it reinforces this, it doesn't reinforce this, it doesn't, it goes against this. So if we have something that...
Okay, but where are you adding this 60% thing to? So these are all logical variants.
These are all probability
so
variants,
far, not necessarily certain what these are composed of, but that's not relevant. So you're trying to add a supporting claim for?
I'm saying there's a supporting claim, like this model evaluates the...
Just write it.
Yeah, let me write it. Model M evaluates probability of temperature increase. So this would be in support of, and then I say, well, I'd probably say it's in kind of in support of this, but not so much. But I'd add this to the family, and well, it's kind of in support of this.
How do you add something?
It's clearly in support of this. It's clearly not against this. It's clearly against this. You know, I would probably say that it's relevant to this and add it to the family. Like
what defines the family? Is the family all of these claims together?
Yeah, this is a family. This is a family.
And that's determined by the fact that they all share the same base claim.
Correct.
From the model you showed before. What is the base claim?
This is the first one is the base.
Okay, the first one. So if you add, what you're saying is if you add the line 573 to any of these,
yeah,
then you will automatically somehow evaluate whether or not it should be added to any, well, either the base claim or any of its logical variants.
Yes.
Okay. And then you can do that how? So yeah, let's do it line per line. Like what would the compiler do? So you'll...
The compiler would say that this
so let's say it gets added to the base claim because you need to add it to one of them, right? Unless
right.
you...
Yeah, and it makes sense to say it's the base claim. Well, it's kind of weak support for the base claim. It's strong support for the...
But how do you evaluate that? That's you, but how? So you have this logical variant and this parametric, like compile it for me, walk through it. Like what will you evaluate? How will you be able to do this?
Good question. Okay, let me think. I have to be able to say that this is the same base claim, but this is according to a source, model M, and then, you know, and that the source is plausible and da 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 da. So basically, we have a source asserting the same thing as the base claim. So basically, the base claim is supported by model M, really, but only with another probability variant. So a probability variant of the base claim is supported by model M. And then that probability variant becomes is compatible or incompatible. So the question is there overlap with this is a probability range, and this is an absolute. So in a way, this is 100%. So this goes against this purely. Here there is overlap. 60 is compatible with more than 70%.
Okay,
here
so
there's
in the
no
case,
overlap, and here there's no overlap. So it would
in the
say,
case of a probability variant, you're saying that if there's no probability assigned to the base claim, then it's assumed 100%.
yes.
Yeah. Meaning that if the probability is lower,
It kind of goes again. But if that's a bit subtle. I'm not sure how to do that, to be honest. If suppose the probability is 90%, is that supporting? Not supporting? If it's 99%, is it supporting? Yeah, psychologically it is. In absolute terms, it isn't. But it's kind of weakly supporting, or the notion of support itself has to have a kind of
because right now we only modeled support as either supporting or not supporting. So
yeah, if I say, well, this is 80% likely, is that support? Is that not support? It's kind of support.
So maybe this example is a bit too complicated for just.
No, it's a very real example. On the other hand,
yeah, but it's not really answering the question what would happen. I mean, if you don't even know
what would happen is, as I'm saying, it will look at overlap, and in strict terms, there is overlap with this one. There is no overlap with that one. So this will be supported and this will be opposed. Now, is the support being determinant? Like I expect the support opposed to have also a quantitative.
Yeah,
like
but to compile that, the overlap can only be assessed if it's the same instance of logical variant, meaning if there's like, there's overlap in the parametric claim and it's the same instance of that specific claim. So you do some equality checking in the specifics of the logical variance. And then to evaluate that, you are operating on specifics, you're not operating on logical variance. So my point remains, the only abstraction you're using here is to have a set of related base claims. That's all you're doing.
Okay, well. And what if model M evaluates probability at greater than 2.5 at 60%? So this is it. You need to look at the parametric values to know, and it's not in the probability set, but it's in it because it has the same structure. You may want to look at the fact that this actually supports that, and even may support that or not clear, but it certainly supports that, but it does go against this.
All I'm saying is that it sounds very much like the only way to implement this is by using the specific instances, not the abstraction. That's and we're talking about how would you implement it on the abstraction. All you're saying is that you need to do a evaluation on all of the set.
And what I'm saying is I'm looking at range overlap. Like if in this case, I will notice that greater than 2 is included and greater than 2.5. I'm using set theory, and hence I can apply that this also applies to the 50%, and greater than 50% is included and greater than 60% plus or minus 2. So there is overlap. So again, it supports that.
Yeah. So the abstraction would be that you just iterate over the set and then you might add it to some other ones part of the set or not.
Yeah, absolutely. And but I'm saying it can be done at there's probably a multi-method. It's not necessarily a method in the abstraction, but it's a multi-method that uses the abstraction that compares the two sentences and notices that there is or isn't overlap in the probability and parametric values.
Yeah, I mean, yeah. Just the examples I see, they all seem very much related on the things in the set being of the same instance type. Because otherwise you're going to have like a big specialized implementation, each of these that needs to evaluate all the specific instances. the strategy pattern doesn't apply here.
To some degree, I think this is premature optimization again. This is we're arguing about things that will only matter when we actually are implementing. So yeah,
I'm arguing the
there's no
abstraction
use to it,
doesn't
we don't need it.
exist. I'm saying the abstraction doesn't exist.
It conceptually exists. It exists as conceptually a relationship between claims that has its own set of rules that dictate how the support of one claim affects the support or opposition of others.
Yeah,
that is the abstract notion of it.
But the abstraction, I think, should be the set and the relation. I fully agree with smaller than, greater than, equals, but that is one specific type of relationship which has an associated set of sentences. What we're discussing right now is whether or not that's the same abstraction or there's a useful common abstraction to that and negation and maybe probability.
I mean, useful comes in when we're trying to implement. I mean, it's what's not useful is arguing against an abstract class when it does no harm, right? What does it help?
Premature.
It does no harm. No, it does no harm. Seriously, because for example, no, when it's useful as a piece of word, as a point of discussion. Because what if I say that the mutually exclusive claims have some sort of logical variation set of rules on them, and it follows the same rules, because when you support one mutually exclusive claim, you're opposing the rest. And if you're going to implement scoring or whatever, you know that you have to adjust the scores based on how supportive one opposes the other. It's the same thing that comes out in terms of comparisons or other types of variants. And if we're not going to use it in code, that's cool, that's fine. But that
then this is again a weird. Yeah, okay, fair enough. As a concept, as in terms of language, I agree. But I mean, we are talking about modeling and software, and in software, abstractions that are not really certain or clear on abstractions are needed.
No, yeah, I agree with that, but I think we haven't gotten to the use cases that actually would decide if it's necessary or not yet.
Fair enough. If it's just modeling a concept that's not necessarily implemented, then I'm on board. What I was arguing,
it's not required to implement.
No point.
I agree with that.
I'm still, fair enough, and there I'm still working. Like, for me, this is not a finished model. I was pointing at concepts here, but I do think the notion, forget the class diagram, but the notion of this is the same claim, modulo, negation, probability, blah, blah, blah. I think that's a useful concept. This being able to say from a claim, this is the base claim, this is the family of probability variance. That's a useful concept. And the parametric variance, same thing. You have a base claim. Here are all the parametric variants of that claim, which are actually, you'll notice the parametric variants are not defined on claims, they're defined on entities. So again, it's the parametric variants are usually on the entity.
It overlaps to me a lot with our discussions on generic specific, right?
Yep. And the whole question of, is there overlap? I said at some point in our conversations, what's really important is the set theoretic thing. Is there overlap? Is there difference? Is there this?
Actually,
is there that?
I see them as being
distinct. Specialization, right?
I see these as being very different things, because there's no, the logical variant has to do with, if one is true, then the other can't be true, or the other must be true, or whatever. It's that kind of relationship. Whereas general to specific is, just because a specific case is true doesn't mean that the general case is true, and vice versa. And if siblings, it's a separate structure or relationship. I have a hard stop, so I have to bow out. But,
okay.
It has been very interesting.
Yeah, let's go. But I'm curious what Felix was saying. There was something there that I wanted to capture.
No, Marc-Antoine, you said like there's set theoretic concepts like difference, and I said like in the variance, if there's a subset, like even multi-dimensional subset, then it's the specialization, right? Was just a question that popped up in my mind.
I don't know if it's the same as specialization, and I don't think of it that way. Though of course one could. But it's, for me, specialization is at the ontological level, whereas subset need not be at the ontological level, if you see what I mean. When I say probability is between 20 and 30% versus 25 and 26%, am I making an ontological claim, or am I making
Okay, for probabilities, I don't know, but like for numbers, this made sense to me. Like this happened between
probabilities are numbers,
1990 and 2020,
Oh yeah, okay.
and this
Yeah,
happened
exactly.
between 2000 and 2005.
right? And you would argue that this is specialization?
I was wondering that, yeah.
Yeah, I think for me, inclusion is a distinct operation than specialization, but I probably have to justify this. You are right that it does require justification. As I said, the notion of abstraction is something I'm really banging my head against, because abstraction is always requires an axis. Like when you're saying this concept is an abstraction of these other more concrete concepts, you're saying, well, I'm grouping these concrete concepts and choosing, so to speak, an axis of variation that I say that they're on the spectrum of.
Yeah.
And I could say,
I think that in other words, like my definition of abstraction is basically a summary or a biased summary even. And this is very similar to like the spectrum you mentioned.
Did you say biased summary?
Yes, biased in the sense of I can have an abstraction that leaves out specific details.
Yes, and there I agree totally. The abstraction, okay, first the abstraction is an operation of the mind, and that it's biased in the sense that we choose to leave out one of the axes of description.
Yeah, but you can also choose to put in an axis. I mean, I don't see bias working one way or the other. I don't see why that matters.
No, but
just saying abstraction is about hiding stuff in general, I think, because else you don't need an abstraction. Like it's the map and the territory thing.
And it's an operation of mind. It's not biased in the sense necessarily negative bias, but there's a construction of mind arbitrariness.
Or more inclusiveness. Which is, yeah, for me, an abstraction is always more inclusive than the specific.
Of course.
Yeah.
But it also erases the distinction. And the question is, which distinction is it erasing?
And that can be mapped along multiple axes, and I don't intend to model that anytime, but I understand what you mean by that. But why did we bring this up? Why did you bring this up?
It was about, no, Marc-Antoine.
The overlap with this and yeah. So for example, in Tim's case, with smaller than, greater than, or
because the notion of containment and difference is relevant to both. When we do parametric variance, then we have numeric, easy to calculate containment and difference. But in the case of abstraction, containment and difference are not as easy to infer, but they're still the relevant operation. We're still, when we are proposing an abstraction and asking, for example, have we exhausted the cases? You know, this is true because it's true in this case, in this case, in this case, and those cases are exhaustive. And that's a statement. We're making the statement that the abstraction minus the union of the subcases we've treated is empty. There's no, the difference of the abstraction versus the cases we've treated is empty. So that's a case where we're interested in difference, set difference. And so I think that set difference is a fundamental thought process, which is which is common to parametric variation and abstraction. And I think it is the fundamental thought process. Now, parametric variant allows, you know, finer automated notion of difference, but what is the fundamental thing is there a difference? Is there an exception to the two abstractions?
I think we have to go, like, have a session and go deep into that one. That's
Yes.
probably a good idea. I have another question. Is negation just a special case of mutual exclusiveness, or is there something else?
Yes. And what Timothy is arguing for always is like having some type of abstraction for mutual exclusiveness. But I think it's different from the logical variant on this diagram here.
Yeah,
which is
because like the thinking process is maybe
not, but that's what we're trying to understand.
Maybe negation is strange to model because it's actually mutual exclusiveness, and we have to model it more generally. Because negation, we say, okay, we have these negation edges and we cannot have triangles and so on, but maybe we have to model it in a different way with mutual exclusion.
Yeah, but so again,
if this is exactly what I'm arguing when I'm saying, for example, greater than 50%, less than 50%, blah, blah, blah. Some of those are mutually exclusive or not based on probability distributions. And the question is there overlap? Is there difference? This is exactly what I'm saying is the real question. Mutual exclusiveness. Some of those are mutual. Some of those probability distributions are mutually exclusive and other are compatible.
Yes, but the mutually exclusive case is, well, easy to understand, first of all, and it resolves automatically whether or not something supports or opposes another one. If you support one, it means that it opposes all the other ones, and indeed negation is one specific case of mutual exclusion. So if you go back to the other diagram, I'm fully on board if you rename logical variant here to mutual exclusion, then you could even say, well, negation is actually just an instance of mutual exclusion with two sets that are mutually exclusive, with two claims that are mutually exclusive. So I'm with Timothy that far, but I'm trying to understand indeed how you generalize this beyond that.
But it's not only mutual exclusion, right? The presence of overlap, like if you have partial overlap, it's not exclusive, but there's actually, and this is really interesting, the intersection of two probability distribution gives you a new probability distribution. So there's an operation, and the question is mutual exclusion is the special case when the product, the probability distribution product is 0. But that's one special case. But the general thing is there overlap?
Yeah, I can
so
see what you're hinting at.
It's all about set theory in the end.
And it's actually a bit different because I'm using probability distribution, so it's fuzzy set theory in this case.
Yep.
But it's interesting because once you mention, because anything needs to be discussed, and also why mutual exclusion is way below in my backlog, even though I find it a valid use case. The way I start modeling that is that you also need to be able to argue about the set itself. And how the set itself, are these actually mutually exclusive?
Yeah, absolutely.
The what? What did you say?
Like, are two claims mutually exclusive or not? So
yes, it's absolutely valid. Yes, it's a use case.
Which could be part of the process then, right?
Or not. Yeah. Or I mean, yes, true, it could be part of the process, but that doesn't mean it's not used as an argument.
Yeah.
It being part of the process doesn't mean it's not used as an argument. And
I want to see a lot more real world arguments, because I mean, yeah, that's not part of what we do here on Fridays, but a lot of these claims of 60, 70, this and that, like, I think in practice, it's really, I understand that you want to abstract this away and model this so that you can have this automatic, oh yeah, okay, that also means we can add support to these other claims. But I still...
Aren't these, the sentences Marc-Antoine presented as an example, aren't such sentences appearing
real world
in
examples,
research papers, for example?
Yeah, but do we want to add argument maps for research papers?
I do.
I think we want to, yeah, because that's part
in scope for me, yes.
Argumentation. That's
yeah, but do you want to to which degree are we fine with saying model M says global warming? Like, what level of what level of specificity do you want to map is a question here. If you can map a claim that you want to find support for, and you can then say, well, this paper said 20%, this paper said 30%. I'm more thinking like that's sufficient if then the base claim is, well, it is a problem. I really don't need to model that, oh, it's 30 or 40 or 80. Those are the specifics where I go like, well, if you're digging that deep into an argument map, if you have a list of all of the data points, right, linking back to the research papers, do you really need to automate to say, oh, well, based from all of those supporting things, we can calculate an error margin and all that stuff?
I think it's not about calculating. It's about actually being able to representing. Yes.
Yeah, I don't think the calculation is possible that way. I would even agree with that. But I'm saying calculating that because this paper is giving this number, is it or is it not opposing that other paper that says it's, you know, if this paper says it's in this range and that paper says it's this range, are they disagreeing? For me, that's calculatable. Whereas coming from all these papers are giving these different ranges, and hence here's the composite range, that I don't think is computable. But saying these two papers are saying those ranges, do those ranges overlap? Yes, for me, that's in scope.
Yeah, I'd have to see it in argument map form.
Okay. I think I also
maybe it's a good exercise. Yeah, me too, by the way. I just got a call. I'm going to call back. It would be interesting to try to actually map two research papers that make similar claims like this. I think I wouldn't map it the way you're envisioning. I'd probably do it much more flat, less deep.
Food for thought.
Yes.
Yeah.
But anyway, good session. Otherwise, I think I'm happy where we started discussing these more complex cases. I'm glad I got Tim to start to reintroduce something like context or disambiguation. That's something I want to pursue next time. How does he see doing that?
Yep.
Ciao, ciao.
Sounds good.
See you next
time.
Have a good weekend.
You too.
You too.
Bye.